lot for me going through the odds. I'm just going to go through the odds of learning target D and E, worksheet number 3 here. First of all, learning target D, before we start, we understand that after the first step, we will have fractions, okay? So basically, the biggest thing you need to understand for this learning target is we're going to multiply by something that's a fraction over that same thing, all right? Now, first of all, we'll get there in a second, but this first problem, you're looking for a common denominator. You already have one. This isn't going to happen all the time, but we do have a common denominator, so we literally just want to write it all over w plus 5. So now I just go across the numerators in combined like terms. I don't want to factor the top in the first step. So actually, 2w plus 3w is 5w, and then we have just a minus 9 there. Now, I want to try to pull a GCF out of the top. Nothing comes out of 5 and 9, so that's actually nowhere else I can go here. This w does not cancel with that w because they're parts of binomials there. So that one shouldn't be too bad. I'm not going to do number 2, but if you notice, number 2 is very similar as far as having an LCD. All right, so then we get to number 3. And the first thing we need to understand about number 3 is that there is not a common denominator. So what does this whole common denominator thing mean? It means I need a number that both of these 5 and 20 can go into. Now I'm going to try to help you out here. What you should do first is check and see if 5 goes into 20. Check and see if the smaller number goes into the bigger number. Okay, it does. So that means that 20 is going to be our LCD as far as the numbers go. So we're going to put a 20 right up here for the LCD. Now, I need both of these denominators to be the same. I can only multiply. So I can't make a 3 smaller, but I can make an x bigger. So that's why I just look here. I look at the variables. I see where are there the most variables? Right here, 3. So I'm going to say 20x to the third power is actually my least common denominator here. Okay, so now what am I going to do? I'm going to actually carry out and get 20x cubed. Well, if you look at the right side, we already have that. So on the left side, I'm missing what? Well, how do I get from 5 to 20? I'm going to multiply by 4. How do I get from x to x cubed? Well, I'm missing 2 x's, so I'm going to multiply by x squared. I'm mathematically not allowed to do that. I have to do it to the top and the bottom to make it mathematically legal, okay? So now I'm actually going to multiply here, and I'm going to take my time on this review and make sure we're seeing every step here. That's 16x squared on the top, and that's 20x to the third power on the bottom. And then over here, I'm completely leaving it the same. I have 20x cubed over there on the bottom too. Well, now that I have a common denominator, I just put both the top and the top left, top right, together with one common denominator. So that's going to be 16x squared minus 9. Now I realize that I just made a mistake. So look back at the problem right here. Mistakes happen. I'm a human. But I'm not going to re-record. I want you to see if you can see the mistake I already made. Hopefully you see it. But I'm going to take this red and I'm going to correct that. 4x squared times 4x squared is actually 16x to the fourth power. Okay, so sorry about that. So this here should be a 4. Now, technically right here, this is a difference of perfect squares, if you see that. And if you can hear my words right now, I'm not going to write it. This would actually be factored out 4x squared plus 9, 4x squared minus 9, and we could actually keep going with one of them. Here's the deal. That's not my intention for you to try to get a really tricky factoring one. Nothing is going to end up canceling in this problem. So even if you factor the top, it's not going to lead to canceling. Sometimes it does. Okay? So that's our final answer. Looking down at number 5. All right, now it's like, well, there's an x plus 6, and there's a 6. You got to get those separated in your brain. That's x plus 6. That's a different 6. Think of it that way. So my LCD over here is literally going to be 6 times x plus 6. So what am I missing on the left side here? Well, I'm missing out of this the x plus 6. So I'm going to multiply the top, and I'm going to multiply the bottom, by x plus 6. And then on the right side, what am I missing? I'm missing just the number 6 from that LCD. All right, so now we need to actually work through this, and I'm going to work through this in one step here. Okay, I'm going to have a common denominator after this. My common denominator is going to be 6 times x plus 6. What am I going to have on top? Well, if we look at what's happening on top, 2x times x is actually 2x squared plus 12x. And on the right side there, we have plus 18x. All right, so now remember, through these we've been saying leave the leave the denominator the same, leave it factored. So that denominator is just going to be 6 times x plus 6. But on top there, we can actually put 2x squared there, but then we can add those like terms, which is 30x. And we're still not done. So I'm going to go over here now. The GCF of the top is 2x. So on the inside, we're going to have x plus 15 there. We always want to check at the end if we can factor the numerator and actually get that there. So we're there, and then the bottom is 6 times x plus 6. And there actually was a purpose in factoring here because the 2 and the 6 are now part of monomials, so they can reduce. 2 goes into 2 one time, 2 goes into 6 3 times. So the final answer to this problem here would be x plus 15 on top, and on the bottom, 3 times x plus 6. That's going to be our final answer there. Okay, now this is going to happen once in a while, and it's happening on 7 here. Before you try to get an LCD, give a quick check to the bottom. Can this be factored? And it can, and it makes life so much easier for the LCD when we see that. So this one's actually going to be w plus, using our factoring hints, and it actually is going to work out to 2 and 2. So don't look at it like this. Look at it as w plus 2 times w plus 2. All right, so w plus 2 times, okay. Well, what's this missing? Again, if I go off and read over here, w plus 2 is part of my LCD, but that's not the whole thing. You got to have that twice here. Okay? So now what's this one missing? It's missing one of the w plus 2's. Remember, the goal is to get the denominators the same. Now I have that. So over denominator of w plus 2, w plus 2. The top is now going to be w on the left. Don't have to multiply the left by anything. It's already got the LCD. So plus, and then we distribute here to get that 2w plus 4. So now I have 3w plus 4 on top, and then w plus 2, w plus 2. Last thing is to check the top. There is no GCF. Can't cancel anything. There's our final answer. Okay, moving on to the back now. Now we got to switch gears from what we're doing on our learning target. Our learning target now is solving rational equations. Well, just like the other side, we want to find an LCD and think about an LCD first. But when you get the hang of these, okay, so we have a 1, and a 5, so that's going to be 5. And just like we said on the other problems, you want to take the largest number of variables you see. Well, the highest number I see is actually a squared. So I have 5x squared as my LCD. Now here's the difference. You are not going to have fractions. No fractions after you maneuver the first time. Now you might have a fraction in your final answer, but I'm talking about throughout the problem. If you look back at the other problems that we've been doing, Learning Target 14D, we've had fractions. Fractions all the way to the end. Not after the first step here. So you're going to multiply by, hopefully you're hearing this. Oops, didn't mean to do that. You are going to multiply by 5x squared over 1. Not by what's missing over what's missing. The goal here is to get the denominator to 1. So 5x squared over 1. 5x squared over 1. Now watch very carefully on what cancels. First of all, just look right here. the x squareds are going to entirely cancel here. That's not a negative. Be careful. That's a multiplication. So the x squareds completely cancel, but we have a 5 times 1 on top. So that's going to be just a 5 right there. Okay? Now, x squared over x, the x squareds are top heavy. So that's going to leave an x on the top. Now, this is where you got to be very careful. There's a negative. 1 times 5, this canceled and left an x. So we have minus 5x that's coming out of that. And then over here, 5x squareds completely cancel with that 5x squared. It's not like there's nothing over there. 1 times 1 is 1, so you got to leave that 1 there. All right, so now solving the problem, we want to subtract 5 from both sides. And then we want to actually have negative 5x equals negative 4. Divide both sides by negative 5. You're going to get 4/5 is the answer to this problem. Again, fraction at the end is okay. Just notice how they all were gone after the first step. Okay, look at the top. You might be thinking, oh, GCF at the top. Remember, you do not need to do any factoring. You can't do factoring at the beginning of the problem. What we want to do is be like, what's our LCD? Well, I see a B. I see a B. I see a 1. My LCD here is B. So what do I multiply by? I multiply by B over 1. I multiply this by B over 1, and this by B over 1. So what's going to happen nice on the left side is that the b's are gone, and all we have is 3b minus 3. And then over here, the b's cancel as well. And then we have just 2b, or not to be. That is the question. But we actually have 2b plus 6. That's just sitting there because the b's canceled. And then we have minus, don't miss that b on the back end, 4b. Okay? So now we have an equation that we should know how to solve. Getting rid of that there. So now what am I going to do? Well, I'm going to personally just leave the left side the same. And I'm going to say 2b and negative 4b is negative 2b plus 6. I'm just combining those like terms there. And then I personally like to add 2b here. So I have 5b minus 3 equals, those cancel, just 6. And then I'm going to add 3 to both sides. Sorry, I'm going too fast for the pen. 5b is equal to 9. So we're going to get a b value of 9/5 for that problem. Okay, a couple more here. Practice when the denominators are 5 and 6. So hopefully you see this, that your LCD is actually 30 here. Oh, does 5 go into 6? No, it doesn't. So I double 5. 10. 6 doesn't go into 10. Triple 5. 15. 6 doesn't go into 15. 5 times 4 is 20. 6 doesn't go into 20. 6 doesn't go into 25, but 6 finally goes into 30. Okay, so actually on this one, we want to multiply. Don't forget it's an equation. This is mathematically legal. I'm going to multiply by 30 over 1 on both of them. Okay, you will not get put into math jail for doing that. All right, so 30 over 5 is actually 6 over 1. And over here, 30 over 6 is actually 5 over 1. Now I'm going to grab the green pen here and make sure you are seeing this. Be very careful. These are both in parentheses here. So what's going to happen now is that we're actually going to have to distribute this 6 through that binomial. So we're going to get 6x plus 12. And on this side, it's going to equal bring the 5 through, and we're going to have 10x minus 15. All right, so there's our equation to solve. Me personally, I'm going to get the 6x's off of this side and bring them over here. So now we're going to have 12 equal to 4x minus 15. Then I'm going to add 15 to both sides. And I have 27 equal to 4x. Last step, another ugly answer, is going to be 27 over 4 is our final answer to this problem. All right, just taking a glance at the next problem. Actually, I want to look over here just real quick. I'm not going to do these problems right now. But if you look at number 14, if you were to do that problem, what's your LCD? Well, the first thing you need to do is factor this bottom. And after you successfully factor the bottom, you'll see that the LCD is actually x plus 3x plus 1. which is one of the factors here. So you'd multiply everything by that entire LCD. Please look at my solutions online to see how we do that. Number 16, same thing, except for this is x plus 6, x minus 6, right there. Then you get your LCD that way, which is the entire LCD there. Okay, over here, this one's already kind of factored for you. So you're like, well, what's my LCD? Well, x plus 3, and then 2. So my LCD is literally just 2 times x plus 3. And don't forget what we're going to do. We're going to cross stuff off. So if I multiply this one by 2 times x plus 3, over 1, that's going to nicely cancel my x plus 3's. And then 12 times 2 is going to leave me just with the number 24 right there. Beautiful. Well, what happens if I do it on this side? 2 times x plus 3 over 1. These 2's are gone. The x plus 3's are gone. 1, 1, 1, 1, just 5x. And look how nice that problem works out. Okay? And then we're going to divide both sides not by 24, but by 5. Okay? So you're going to get, as a final answer, 24 over 5. Some ugly answers. You can go back and check them. They're kind of hard to check because they're ugly and they're fractions. But I just want to say one more thing. 13 and 15 here, if you wanted to, you could have cross-multiplied. So if you're comfortable with cross-multiplying, that works for those two. Doesn't work for all the problems. Again, whoa, I cannot stress enough that I would like you to check the solutions. Go try the even problems if you haven't already. Go check the solutions online, okay, and see if you can tell from the solutions what's going on. But put in some time, and then this could be you after your test. And you could be thinking after your test, wow, I did a lot of studying for my test. That was rational. That was not an irrational thing to do. That was rational studying for my test. All right, I'm done. Have a nice night.